Welcome to this presentation. It's on question 13 of STEP paper 1 2001. Let me read it to you. 4 students, one of whom is a mathematician, take turns at washing up over a long period of time. The number of plates broken by any student in this time obeys a Poisson distribution, meaning that the probability that any given student breaks n plates is e to the minus lambda to the power n over n factorial for some fixed constant lambda, independent of the number of breakages by other students, so the students are breaking plates independently. Given that 5 plates are broken, find the probability that 3 or more were broken by the mathematician. Okay, well, I'd like to do this in a couple of ways. The first easier than the second, but the second just to give you an idea of what you could have done if you hadn't noticed the quicker way of doing it the first way. So here, let's have a look. Let's draw the 5 plates. Oops, that's not working very well. And the key thing to notice is that if a plate is broken, the probability that the mathematician broke it is a quarter, because they're all working independently, and breaking one plate independently of another plate, one student working independently of another. There's 4 of them, all equally likely to break plates, so the mathematician's got a quarter of a chance of breaking any given plate. So what we've got here is a binomial distribution. So let's have a variable x, binomial distribution, where there are 5 plates, if you like 5 trials, and a quarter of a chance of the mathematician being the one who breaks that particular plate. We're given that 5 plates were broken. So what we've got to work out is the probability that, in the end, that x is greater than or equal to 3. So to do that, we're going to work out the probability that x equals 3, and the probability that x equals 4, and the probability that x equals 5. And we're going to add those up, and that will give us the probability that we want. So this is just a binomial distribution, so the probability of x equals 3 is 5c3 p to the 3 q squared, where p is a quarter and q is going to be 3/4. So let's just work that out a little bit more. That's 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. Okay, so that's 5 factorial over 3 factorial times 2 factorial times a quarter cubed and 3/4 squared. Doing this rather slowly, but you can see that those all cancel, but that's going to cancel with that, so we're going to have 10 on the top, and over, this is going to be equal to over. I'm going to leave it as 4 to the power 5 on the bottom for a moment, and then at the top we've got 10 times 3 squared, and that is equal to, well, 4 to the power 5. Well, it turns out that's 1024. You might notice that's 2 to the power 10, 2024, or 4 times 4, 8 times 4 times 4, 64. Have I got enough 5s there? Sorry, 4 by 4 is 16. 16 by 16 is 256, and another 4 of those is 1024. And on the numerator here we've got 90. Okay, so let's work out the others here. Probability that that mathematician breaks 4 of them is 5c4 p to the 4 times q, which is equal to just 5 for 5c4, 1 over 4 to the power 4, 3 over 4. This one's a little easier, so we end up with on the numerator 15 over 4 to the power 5, which is equal to 15 over 1024. And the last one, the probability it's 5 is the easiest of all. That's 5c5, p to the 5, q to the nothing, forget that, which is equal to 1. 5c5 is 1 times a quarter to the power 5, which is equal to 1 over 1024. So taking that all together, the probability that x is greater than or equal to 3 is equal to the sum of these, which is 90 plus 15 plus 1 all over 1024, which is 106 over 1024. Maybe that could cancel slightly, but as a decimal it's 0.1035. I did this before and looked at it on my calculator. So that's the first way of doing it, and that's by far the easiest. And to do that you have to notice that it's a binomial distribution and you don't have to bother with lambda and the Poisson distribution at all. That's the easy way. But let me now show you the more straightforward in some ways, but longer and I suppose altogether slightly harder way. We'll pause for a second.